Hello viewers, welcome to the channel Amazing Civil Engineering Studies. Here we will learn about different concepts related to civil engineering. Time to enter the world of civil engineering. Please subscribe to the channel and press the bell icon for more new updates. In today's video we are going to discuss about culvert and flyover. What is bridge? A bridge, a connecting structure, create bonding between different disconnected parts of a country, two banks of the ocean, or parts of two countries. A bridge is a structure built to span a physical obstacle, such as a body of water, valley, or road, without closing the way underneath. It is constructed for the purpose of providing passage over the obstacle, usually something that can be detrimental to cross otherwise. Information on bridge. This first bridges made by humans were probably spans of planks or wooden logs and eventually stones, using a cross-beam arrangement and simple support. Most of these early bridges couldn't support heavy weights or withstand strong currents. It was these inadequacies that led to the development of better bridges. The oldest surviving stone bridge at China is the Zhaozhou Bridge, built from 605 to 595 AD during the Sui dynasty. The bridge is also historically significant as it is the world's oldest open spandrel stone segmental arch bridge. However, bridge design and construction then may not be considered bridge engineering practice by today's definition. Instead, work was done based more on experience as opposed to quantitative planning as done now. Bridge engineering today uses calculus-based analysis and detailed planning. Materials used in bridge construction have also changed noticeably through a good number of years, from mainly natural materials such as stones and wood than to mainly man-made materials such as steel and Portland cement concrete today. Due to great improvement in the strength and production quality control of these materials, bridge components have become smaller, thinner, skinnier, and lighter to reduce self-weight and be more economical. In 1866 Weiss and Konen in Germany conducted a series of tests on reinforced concrete beams, Heinz and Laurie, 1984, which started the era of concrete for bridge construction. More tests and research work were done in the following decades. The first bridge using reinforced concrete in the world was credited to Munier in 1867, Heinz and Laurie, 1984. The first bridges using steel are believed to be constructed in the United Kingdom and the United States in the 1880s. These pioneering projects began what is known today as modern bridge engineering. Another important aspect characterizing modern bridge engineering is the tools used to perform quantitative modeling and planning. They include calculus and calculus-based mechanics, acknowledged as the foundation of modern bridge engineering as practiced today. This knowledge was established in the 17th century. With the new materials and advanced analysis tools, the fast development of modern bridge engineering had its technical strength. The fuel for substantial developments of bridge engineering was the need or desire for economic development, for example. Today's highway bridge technology in the United States is largely a result of the rapid development of the interstate highway system in the 1950s and 1960s after World War II. As a product, a comprehensive highway system has been established, consisting of about 50,000 miles of roadways and about 600,000 bridges. It is also interesting to mention that a number of developing countries are currently experiencing a similar boom in their surface transportation systems. This has become the driving force for bridge engineering development in those parts of the world. Types of bridges. Types of bridges based on span, materials, structures, functions, utility, etc. There are various types of bridges classified based on span, materials, types of bridge structures, functions, utility, and position, etc. A bridge is structure which allows passage over an obstruction. The obstructions may be river, valley, rail route, or roadway, etc. Types of bridges based on type of superstructure. Arch bridge, girder bridge, truss bridge, suspension bridge. Types of bridges based on materials. Timber bridge, masonry bridge, steel bridge, R.C.C. bridge, pre-stressed concrete bridge. Types of bridges based on span. Culvert bridge, minor bridge, major bridge, long span bridge. Types of bridges based on level of crossing. Over bridge, under bridge. Types of bridges based on function. Footbridge, highway bridge, railway bridge, aqueduct bridge, road-cum-railway bridge. Types of bridges based on span relation. Simple bridge, continuous bridge, cantilever bridge. Types of bridges based on utility. Temporary bridge, permanent bridge. Types of bridges based on position of floor. Deck bridge, through bridge, semi-through bridge. Types of bridges based on high flood level. HFL, low-level bridge, high-level bridge. Bridges are classified into so many types based on different criterias. They are explained below. Types of bridges based on type of superstructure. Arch bridge, girder bridge, truss bridge, suspension bridge. Arch bridge. Arch bridge is curve-shaped bridge, in which horizontal thrust is developed and is restrained by the abutments at each end of the bridge. There are many types of arch bridges. In some cases, the arch may be under the deck slab also. An arch bridge is the most popular type of bridge which is extensively used by ancient Romans. The arch bridge is usually made up of stone, concrete, or steel. As the name itself mirroring that, the bridge is in the shape of an arch. An arch bridge is a curve-shaped bridge where the load on the curve is not directly applied straight down, but instead, loads are carried along the curve of the arch to the end of supports, meaning that no part of the bridge takes a high amount of pressure. These supports are also called as abutments. Abutments carry loads of the entire bridge and it is responsible for holding the arch in a precise position. The know of curves, arches, in a bridge depends on stress and loads that bridge should support. The span length of arch bridges is normally up to 250 m, and the roadway of the bridge lies on the arch structure. Advantages of arch bridge: easy to build with the locally available material. These type of bridges are very rigid and extremely strong. Arch bridges are built up with a variety of materials like stone, concrete, steel, etc. Disadvantages of arch bridge: they take a long time to build. It requires a massive amount of building materials to build. Girder bridge: in case of girder bridge, the deck slab is supported by means of girders. The girder may be of rolled steel girder or plate girder or box girder. Load coming from the deck are taken by girder and transferred them to the piers and abutments. Truss bridge: truss is member consisting connected elements to form triangular units. In case of truss bridge, the superstructure is provided with trusses. Generally, trusses are made of steel. There are several types of trusses are available. Truss is a framework consisting of struts, inclined members. These bridges are constructed by using trusses which are comprised of many small elements forming triangular trusses. The span length of truss bridge is in between 50 and 110 m. Trusses are very rigid, lightweight and can support heavy loads. Trusses serve in transferring the load from a single point to the wider area. The weight of the bridge is very less when compared with other types. When the load is applied to the truss bridge, the top edge possess compression and loads are shared among the angled members to supports and then to earth. Advantages of truss bridge: this type of bridge is easily built in the factory and then framed on site. The piers or supports are comparatively less when compared to the beam bridge. They are strong and rigid and very light on weight, possess efficient use of materials. Disadvantages of truss bridges: requires high-skilled professionals to design it. They are more complex than beam bridges in terms of designing. Suspension bridge: in case of suspension bridge, deck slab is suspended with the help of cables and suspenders. These will give good appearance. For long span bridges, this type of suspension is suitable. This type of bridges are constructed by suspending the deck slab using suspension cables. The roadway is hanged using steel cables which are connected to two towers and secured by anchors on both ends of the bridge. In addition to the deck slab, the truss system is also featured with truss system just beneath the deck, which helps to stiffen and to keeps the deck in precise position to reduce the tendency of the roadway to sway. When the load is applied to the suspension bridge, the deck slab possesses compression and then travels up the ropes, cables or chains to transfer the compression to the towers. The towers then dissipate the compression directly into the earth by anchors. The supporting cables which run parallel to the bridge possess tension forces, and these are connected to anchorages. Bridge anchorages are massive concrete blocks which serve in dissipating the tension force to the ground. Bridge anchorages are essentially solid rock or massive concrete blocks in which the bridge is grounded. Tensional force passes to the anchorages and into the ground. The span length of suspension bridge is in between 150 m 2000 m. Advantages of suspension bridge: strong and lightweight. These type of bridges provide long span which helps in crossing the river. Disadvantages of suspension bridge: expensive to build, prone to sway and ripple with the wind, so this type of bridges are not suitable for railways. Types of bridges based on materials: timber bridge, masonry bridge, steel bridge, R.C. bridge, pre-stressed concrete bridge, timber bridge. Bridges constructed using timber are called timber bridges. These are generally constructed for short spans or as temporary bridges. They are not useful for heavy loads. Masonry bridge constructed by using bricks or stones. These are generally constructed for short spans and in low-depth canals. Steel bridges are constructed using steel bars or trusses or steel cables. These are more durable and bear heavy loads. Pre-stressed concrete bridge. If concrete material is placed under compression before applying the loads, then it is called as pre-stressed concrete. To construct pre-stressed concrete bridge, pre-stressed concrete blocks are arranged as deck slab with the help of girders. These blocks are suitable for shorter span too. R.C. bridge. R.C. bridges are constructed using reinforced cement concrete. These are more stable and durable. They can bear heavy loads and are widely using nowadays. Types of bridges based on span: culvert bridge, minor bridge, major bridge, long span bridge, culvert bridge. When the bridge span length is below 6 meters, then it is called as culvert bridge. Major bridge. For major bridge, the span is generally about 30 to 120 meters. Minor bridge. If the bridge span length is in between 8 to 30 meters, then it is called minor bridge. Long span bridge. When the span of bridge is more than 120 meters, then it is termed as long span bridge. Types of bridges based on level of crossing. Over bridge, under bridge, over bridge. To pass over another route, railway or highway, a bridge is constructed to allow traffic. This is called overbridge or flyover bridge. Under bridge. If overbridge is not possible, an underground type bridge is constructed to pass another route. This is called underbridge. Types of bridges based on function. Footbridge, highway bridge, railway bridge, aqueduct bridge, road-cum-railway bridge, footbridge. Footbridge is generally constructed for humans to cross the roads or rail route or any canal by foot. Vehicles are not allowed in this bridge. Highway bridge. Highway or roadway bridge is used for road transportation. These are constructed over rivers or another routes to allow roadway traffic. Girder-type bridges are used as highway bridges over rivers or canals. Railway bridge. Rail bridges are constructed for rail transportation. Truss-type bridges are preferred for railways, but however R.C.C. bridges are also used. Aqueduct bridge. Aqueduct bridges are nothing but water-carrying bridges which are constructed to transport water from source to system. Road-cum-railway bridge. This type of bridge is useful for both roadway and railway transport. It may be of one floor or two floors. If one floor is there, then rail and roadway are arranged side by side. Otherwise, roadway on top deck and railway in bottom deck is preferred. Types of bridges based on interspan relation. Simple bridge, continuous bridge, cantilever bridge, simple bridge. Simple bridge is like simply supported beam type which consists two supports at its ends. For shorter spans, simple bridges are suitable. Cantilever bridge. Cantilever type of bridge have only supported at one end and another end is free to space. Generally, two cantilever portions are joined to make way to the vehicles or humans. Continuous bridge. If the bridge span is very long, then we have to build more supports in between end supports. This type of bridge is termed as continuous bridge. The word cantilever refers that the beam which has only one support and the other end is kept free in space. Cantilever bridges are same to this, but don't think that one end of the bridge is kept free. Cantilever bridges are constructed in parts and the two free ends are connected with suspended deck. Cantilever bridge has a span in between 150 m 500 m. Any bridge is subjected to compression and tension forces. In this type of bridge, the suspended deck is provided to join the two free ends of the cantilever bridge. When the load is applied on cantilever bridge, the top supports are subjected to a tensional force, pulling force, and bottom supports are subjected to the compression force, pushing force, which makes the bridge to be balanced. As long as force is balanced, the bridge will stand in stable position. Advantages of cantilever bridge. This type of bridges are adopted only when the supports cannot be provided at specific positions. Support is required only on one side of the cantilever. Disadvantages of cantilever bridge. Cantilever bridges are prone to high turning stress during construction. If the forces aren't balanced, the bridge may buckle. Types of bridges based on utility. Temporary bridge. Permanent bridge. Temporary bridge. During construction of dams or bridges or during floods, temporary bridges are constructed at low cost for temporary usage. These bridges are maintained at low cost. After construction of original structure, temporary bridges are dismantled. Generally, timber is used to construct temporary bridges. Permanent bridge. These bridges are constructed for long-term use and maintained at high level. Steel or R.C. bridges are come under this category. Types of bridges based on position of floor. Deck bridge. Through bridge. Semi-through bridge. Deck bridge. In case of deck bridge, superstructure or floor of bridge is positioned in between the high flood level and formation level. Through bridge. In case of through bridge, superstructure of bridge is completely above the formation level. Semi-through bridge. If the superstructure of bridge is partly above and partly below the formation level, then it is called a semi-through bridge. Types of bridges based on high flood level, HFL. Low-level bridge. High-level bridge. Low-level bridge. The superstructure of bridge is generally below high flood level. So, whenever floods occurred, these are submersed in water. So, these are also called as submersible bridges. These are generally constructed for unimportant routes with low cost. High-level bridge. High-level bridge is non-submersible against floods. It is well above the high flood level and constructed in important routes. Cable-stayed bridge. This type of the bridge are modern bridges, and it is similar to the suspension bridge. In this type, cables are connected directly to the tower instead of suspended cables. Tension is constantly acting on the cables, which are stretched because they are attached to the roadway. This type of bridge doesn't have any anchorages to bear the compression and has only one tower to carry the compression. The span length of cable-stayed bridge is in between 500 m 1000 m. In this type of bridge, the cables are directly connected to the roadway at different points radially, and towers alone bear the compression forces. Importance of bridges. Road or railway traffic can run uninterrupted in monsoon, saving in time and fuel. It improves the aesthetic of a road. Distance between two places can be reduced. Agriculture products, industrial products, and raw materials can reach the industries quickly, which helps in the economic development of the area. Construction of a bridge on railway alignment at level crossing reduces the number of accidents. Bridges are important from a military point of view. Bridge components and their function. The main components of a bridge are substructure, superstructure, adjoining structure, substructure. The components of the bridge below the level of bearings is known as substructure. It consists of the following. The function of the substructure is to support the superstructure components and transmit their loads safely to the subsoil. Substructure components of bridges. The components involved in substructure of bridges are piers, abutments, wing walls and the returns, foundation, parapets and handrails/guard rails or curbs. Piers. The piers are vertical structures used to support deck or the bearings provided for load transmission to underground soil through foundation. These structures serve as supports for the bridge spans at intermediate points. The pier structure has mainly two functions. Load transmission to the foundation. Resistance to the horizontal forces. Most of the cases, piers are designed to resist the vertical loads alone. In areas which lie in the seismic zone, it is recommended to design the pier for lateral loads also. Most of the piers are constructed using concrete. Steel for the construction of pier is used in very few cases till now. Use of composite columns, i.e. steel columns filled with concrete, is used as new technology of pier construction. The pier is a vertical member that resists the forces by means of shear mechanism. These forces are mainly lateral forces. The pier that consist of multiple columns are called as bent. Piers provide intermediate support between two bridge spans. Bridge piers mainly support the bridge superstructure element and transfer the load to the foundation. Pier must be strong to handle the horizontal as well as lateral. Piers are known as compression members of the bridge. Types of piers in bridge construction. There are different types of piers based on the structural connectivity, the shape of the section and the framing configuration. Based on the structural connectivity, the pier can be classified as monolithic or cantilevered. Based on the shape of the section, pier can be classified as solid or hollow, hexagonal, round, or octagonal or rectangular. Based on the framing configuration, the pier can be classified as single or multiple column bent, hammerhead or pier wall type. Abutments. Abutments are vertical structures used to retain the earth behind the structure. The dead and the live loads from the bridge superstructure is supported by the bridge abutments. The abutments are also subjected to lateral pressures mainly from the approach embankment. The design loads on the abutment is mainly dependent on the type of abutment selected. The sequence of construction. The figure below shows the primary functions carried out by an abutment. As seen from the above figure, the abutments have the design requirements similar to retaining walls as well as in pier construction. The abutments are primarily designed to resist the overturning and sliding. More focus is on the stability of the whole system. The special care has to be provided for the foundations of abutments. The abutment foundation must overcome the problems of differential settlement and excessive movements caused due to lateral forces or loads. The below figure shows the components of abutments. Wing walls and return structures constructed as an extension of the abutments to retain the earth present in the approach bank are called wing walls. This portion will otherwise have a natural angle of repose. These are retaining walls constructed adjacent to the abutments. This wall can be constructed either integrally or independent with the abutment wall. The rear of the wall must consider 3 design loads while designing. This includes the earth pressure from the backfill, the surcharge from the live loads or the compacting plant, the hydraulic loads from the saturated soil conditions. The stability of the wing wall is mainly based on its resistance against the active earth pressures. The structural elements of the bridges are hereby designed and constructed to resist the earth pressures at rest. Foundation of bridges. Foundation are structures constructed to transmit the load from the piers, abutments, wing walls, and the returns evenly on the strata. The foundation provided for bridge structures are deep in sufficient manner to avoid scouring due to the water movement or to reduce the chances of undermining. Parapets and handrails/guardrails or curbs. These components of bridges are not of structural importance, but provided for the safety concerns. These are provided above the decks. This will help in prevention of the vehicle from falling off the bridge into the water body below or as a means for the separation of traffic streams. Superstructure, bridge components. The components of the bridge above the bearing are known as superstructure. The superstructure of the bridge structure consists of deck slab, girder, truss, etc. These components vary based on the type of bridge, whether concrete or steel or composite. Superstructure of the bridge bears the load passing over it. This helps in transmitting the forces formed by the loads to the below substructures. It consists of the following: beams, girders. Both have a similar function to support the roadway and prevent bending. Girder is also one type of beam support. Where loads are heave, girders are used instead of beam support. Beam has a rectangle cross-section, whereas girders have composed of I-shaped cross-sections with two load-bearing flanges and web for stabilization. Bearing. A bearing is provided between bridge girder and pier cap. The main function of bearing to allow free movement or vibration of the top superstructure and reduce effect stress to reach the bridge foundation. The loads received by the decks are properly and safely transmitted to the substructure with the help of bearings. These are components of bridge that enables even distribution of load on the substructure material. This transmission is very essential in situations where the substructure is not designed to take the load action directly. The bearings in bridges allows the longitudinal movement of the girders. This movement is created due to the forces acting on the longitudinal direction. The forces due to the moving loads and the variation in temperature are the main causes for longitudinal forces. The selection of bearing is dependent on certain parameters, which are loads acting, the geometry, the extent of maintenance, the clearance available, the displacement, rotation and deflection policy, availability, preference of the designer, the construction tolerances, and the cost criteria. For the bridge design, all the above-mentioned aspect is considered for the design and the choice of bearings. The designer must consider the bearing arrangement in the bridge construction as a separate system. In most of construction practice, the bearing is selected or the decision for bearing is done in the last moment. This results in increase of maintenance in the future, which must be avoided. Arch, cables. Arched and cable both have specified used. Arched are used for arch bridge construction and cable are used for suspension, cable-stayed bridge, etc. For different types of bridge construction, arches and cable play a vital role. Parapet wall, handrail. The parapet is one of safety component of any bridge which prevent the vehicle from falling off where there is a drop. It is also useful for restricting views, to prevent rubbish from passing below, and to act as noise barriers. Flooring. Its top surface of bridge roadway on vehicle travel. It is made of concrete or bituminous road. Decks. The decking is considered as the road or the rail surface of the bridge. The decks are supported by the girders or the huge beams that is in turn supported by the piers. The whole arrangement is supported with a deep foundation, mainly piles and cap arrangement. Adjoining structures. It consists of the followings. Approaches. It is a structure constructed at the starting or ending of any bridge. Its main function is to provide smooth and easy entry or exit from bridge. Guard stones. They are used to restrict traffic on the particular lane or sometimes as road railing, but are generally positioned to protect a specific object, such as a corner of a street or the side of agate. Planning for bridge construction, including sequence and steps of planning. Planning for bridge construction is required as it has huge impact on life of people. Social, scientific, and technological dimensions for bridge construction must be considered. The decision of providing a bridge across any barrier is to facilitate the community residing on either side of the project. Some major bridges bring benefits to the whole country. For example, the bridges constructed across the river Ganga or the Brahmaputra in India. Another example is the Honshu-Shikoku connection, that has bridges across many islands in Japan. This unique structure construction also benefits more than one country, as in the case of the Øresund link, that is constructed across the Baltic Ocean. 3 dimensions of planning for bridge construction. There are 3 dimensions that are involved in the planning of any mega-project like a bridge. This is considered as an initial step towards the planning of structures that would finally bring up with a project that would be advantageous to the community in all aspects. The 3 dimensions are: scientific dimension, social dimension, technological dimension. Scientific dimensions for bridge construction. There exist certain laws for nature, based on which every structure constructed must perform. Scientists explain these natural forms and the existence of these laws with the help of certain interrelations between certain elements. In one or the other form, the scientists or the engineers make use of pre-existing technologies in nature, that the only difference is the method they use to undergo. Various scientific developments that are made by the engineers based on these, like bringing different alternative materials by chemical analysis, physics to observe and analyze the dynamic behavior of the structure, mathematics used to analyze and determine the forces and the stresses. Hence, efficient structures are evolved with the help of the scientific dimension. Social dimension for bridge construction. Enhancement of quality of life of the people are greatly facilitated by the bridge construction. These structures improve the mobility of people as well as the material. This dimension helps to realize the pros and cons of such construction and their related precautions. Such a huge construction brings changes to the society and the people, but also bring adverse changes to the environment. It is not only required for the bridges to satisfy the need of mobility and the future demands, but also must satisfy the problems related to noise, pollution, during and after construction. As the structure is for the welfare of the whole community, the people are also committed and responsible for bringing their contribution to this welfare in the form of taxes, levies, or in the forms of tolls. This would help in looking the construction as a cost-benefited work and as a means of economic development. The above considerations come under the social dimension. There are also chances for the incorporation of political dimension with the social dimension. This arises in the situation of choice of location or the facility, or in prioritizing the needs for the welfare of the economy. The social dimension has a direct close connection with the scientific and the technological dimension. Technological dimensions for bridge construction. There have been many technological developments over decades in the field of new structures, methods of construction and materials, as an alternative for rare ones and in bringing new machinery that works over human workers. This technology has helped in bringing and refining alternatives in the bridge construction. Now instead of bricks, steel, cement etc., construction are carried out by glass fibers, carbon fibers etc. Going through such innovations in technologies, the first FRP material constructed bridge was in China in the year 1982. It composed of 5 box girders with a clear span of 20.4 m. The development of carbon fiber reinforced polymer IEC-FRP cables, that gain a strength of 3300 MPa and modulus of elasticity of 165 GPa, was also made. The Winterthur Bridge in Switzerland make use of such cables. 2 cables out of 22 are made of this material. Planning sequence for bridge construction. The planning sequence for the construction of a new highway or a railway project is a major part of the project planning. Based on the complexity of the barrier across which the bridge must be constructed, the detailing of the project planning increases, because more investigation must be carried out. In general, the major steps that are involved in the planning for the construction of a new project is mentioned below. Identifying the need for the bridge. Assessment of traffic possible and required in the area proposed to construct the bridge. Study the location. Study of all possible alternatives. Refining and shortlisting all possible alternatives. Identifying conceptual plans for the alternatives. This involves finding the materials, the arrangement of the span and the form. Preliminary design and the cost estimation. Evaluating the alternatives, its risk, and the final choice of decision. Resource source identification by detailed surveying. Implementation with the help of bidding documents. This is followed by carrying out by fixing the agency, the construction details, and their commissioning. Different stages of planning in bridge construction. The major steps that are involved in the planning for bridge construction are: study on need for bridge, traffic assessment, location study, reconnaissance study A, study of alternatives B, feasible alternative study, preliminary engineering A, developing plans B, preliminary design and costing C, evaluation of alternatives, risk analysis, and final choice. Detailed project report. Implementation. A brief idea on each stage is explained in the following section. Study on need for bridge. The decision of having a new bridge in an area is taken as a part of development of the society. This facilitates the feasibility of linking the cities and towns, which gain more importance in the overall growth of a nation. Their need is studied based on the socio-economic viabilities. Traffic assessment for bridge construction. An assessment of the traffic type and its quantum is necessary to decide the following factors: number of lanes on the road or the railway tracks, The geometric design parameters. Benefits acquired by the society. The data collection for this must be done carefully so that a proper idea on how the traffic pattern, the growth strategies such as agricultural, industrial as well commercial developments are influenced. The bridge construction has a huge investment at the initial stages. Once completed, a small variation or renovation is not recommended. So, it is advised to bring a design that considers the future capacity requirements and traffic factors. The traffic assessment study should be considered the following factors into consideration. This mainly is carried out with the help of a traffic planner or an economist. The traffic composition, in terms of light and the heavy vehicles. The maximum and the minimum speed requirements. The annual growth rate and their variations. The design life of the bridge. Location study for bridge construction. While having a location study and fixing the location of the bridge, it is very essential to consider the need and the location of cross-drainage works if any. The cross-drainage work is said to have 15 to 20% of the overall project cost if it must be implemented. Hence, before choosing the alignment for bridge construction, it is necessary to determine all the possible CD works and its effect. The following factors are considered reliable in fixing the location of the bridge. Location chosen over a stream with no bends or meanders. It will be straight in reach. A stream with no branches or tributaries. The location being confined with properly defined banks. If the bridge or the culvert is with the road approach, on either side having maximum extent. If the crossing is normal to the alignment of the road and angle of skew is necessary, limit it. Other than the above specified conditions, the major river crossings of the bridge construction should satisfy the following conditions. River regime. The river upstream must be straight. If there is bend in the downstream, it must be avoided. The river in the reach must be free from whirls, excess current due to eddies. The channel in reach is narrow and well defined. The river regime should have inerodable banks that are firm. If there are no inerodable banks, overgorging, guide banks in dry locations also must be provided. Approaches during floods. The approaches must be secure from flood attacks or any major spills. High expensive approach construction must be avoided. It is recommended to pass through built-up areas, or high hills or through major basin or religious structures. The approaches have a reasonable proximity to the main road. It should not let construction of costly connecting link. The ideal approach will avoid the construction underwater that is highly costly and uneconomical. They should help in a way to bring lesser maintenance to the whole system, hence increasing the life period of the bridges. Reconnaissance survey for bridge construction. This is a pre-feasibility study, which studies the entire reach of the river, that must be crossed, to find out best and suitable position for bridge location. The factors each site satisfies are taken as lists and each is analyzed individually, from which the best consideration is chosen. The final number of feasible sites must be refined down to 3 or 4. This can be done only by going in detail of each site and refining the most suitable ones. During this stage, maps are used to locate these feasible sites. The direct assessment of the site is made to understand the location features, local criteria, studying the existing and growth of traffic with the help of surveys, knowing information from the people residing, simple routes and shortcuts in the area, river flow and its spread are also studied. A feasibility study on the economy of cost, the duration of construction, the sources of resources are also assessed. Now the whole information is gathered and a comparison is made. Based on the discussion and refinement, the best feasible site for implementation is chosen. Preliminary engineering for bridge construction. This stage of planning can be called as a techno-economic feasibility study. Here, the technical details related to the bridge construction is studied in a detailed manner, to bring all possible alternatives to proceed the construction. Mainly it is found that the total cost of the project is plus or minus 15% of the cost that is estimated at this stage of planning. To process the technical study, minimum level of field study and measurements, the location study, and related parameters must be done. This study carried out at the bridge construction site should bring the following tabulated content details. The total length of the bridge. The length of approaches. If detours are present, their respective savings. The anticipated volume of traffic. The distance to the nearby city or town from the site. Expected bridge project period. The nature of stream flowing into the site. The nature and behavior of soil strata for foundation. The construction problems existing with bridges or approaches. Maintenance for the bridges or approaches if any. The internal rate of return or the cost-benefit ratio. The impact on the environment for each element that is noted, must be assigned with a certain amount of scoring and weightage, that would finally help in choosing the best site. Detailed project report of bridge construction planning. This stage is the final stage of planning in the bridge construction, before the commencement of the construction work. Full investigation from the routes is taken and documented. The investigations conducted are: ground survey, soil exploration, foundation details, hydrological data, model studies and analysis. How are bridges constructed? Bridge structure has undergone immense transformation since the beginning of times, such as new sturdier materials, heavy machinery, and new construction methods. The bridge construction has experienced tremendous transformation since the beginning of occasions, such as fresh sturdier materials, heavy machinery, and new building methods. Although construction bridges are a lot easier in modern times, Bridge engineering involves precise physics, vast resources, and thorough planning before and during construction. Before bridges have been constructed, planners must test the site for elements such as the soil strength, depth, and layout of their land. Using computer-aided design, engineers can find a picture of this bridge's behavior under different weights and weather requirements and determine the correct structure. When the planning is complete, workers break ground on the work site, harnessing a variety of materials and assembling structures to keep support even under the flow of gravity. While bridges need careful and precise work, the basic fundamentals of the bridges are made to stand are simple once broken down. Factors associated with building bridges. Before you go into how bridges have been made, there are a few things that you need to keep in mind. The bridges over water can be of both kinds, the floating ones along with the ones that are permanent. Quite obviously, the floating ones aren't permanent and are used only briefly. Hence, they don't require a base. But the permanent bridges require a foundation, and therefore, there are three basic factors which will need to be considered. The condition of the site, the technical ability and engineering ability of the contractor. The technology is available from the country. The first two variables are dependent on the engineers to measure. However, the factor of the availability of technical support depends entirely on the construction equipment that's available. For that matter, it has to be mentioned that there are a variety of types of construction equipment readily available on the market, which are specially designed to support bridge structure. Steps of constructing a bridge. When bridges are built over large water bodies like a very deep river or even the sea, the following steps are followed. Constructing the foundation. To be able to build the foundation, a bed is sunk within the waterbed from the top. It's like a frame to the pillars that can hold the bridge in place. Following that, a service pier is made with the help of rigs. Construction of cofferdam. Around the support rigs and pier, a cofferdam is created. It's a special type of wall that's created surrounding the foundation. Constant pumping removes the water from inside. The area is completely dried out, and after that, the foundation is created. Bringing everything together. Following the construction of the foundation, the support piers are thrown in the yard or cast in place. Sometimes, this process is done elsewhere, and afterward, barges are used to bring everything together. After this is done, the gaps are joined with segments of concrete construction. Sometimes, the sections are supported by huge suspension cables. Since they're drawn into place, they're stitched together. Although these are the most common methods of constructing a bridge, there are different methods as well, which can be followed to build the bridges. Surely, the methods which can be followed for bridges from shallow water differ from those from the heavy water. What is culvert? A culvert is a tunnel carrying a stream under the road or railway. A culvert can act as a bridge for traffic to pass on it. They are typically found at a natural flow of water and serves the purpose of a bridge or a current flow controller. A culvert is provided under highways and roads for a crossing of water, as road embankment can't be allowed to obstruct the water flow. This culvert is ideally suited for a road to limit water flow at a controlled way. There are some common types of culvert, such as pipe, arch culvert, and box. The culvert type is based onto hydraulic, water surface elevation, and roadway height, and other conditions. Difference between bridge and culvert. Difference between bridge and culvert. Sister no. Culvert. Bridge. 1. These components of a culvert are comparatively simpler and include concrete boxes or cells, pipes, a top deck or slab, and supporting parts. These basic components of a bridge, parts of a bridge, are superstructure, substructure, and deck, transverse surface load to their components. 2. The culvert is generally a tunnel-like structure that allows water to pass under a roadway or railway. The bridge is a passage of transportation over a large body of water or physical obstruction. 3. These culverts are usually embedded in the soil, which bears the major portion of the culvert load. Abutments and piers are the supporting structures of a bridge. 4. Culverts are totally enclosed structures that may be semicircular, rectangular, elliptical, or pear-shaped. A bridge is usually straight and linear passage. The culvert is an enveloping structure that 6. The length of culverts is typically not more than 6 meters. A bridge spans from 6 meters to more than 120 meters. 7. No required a deep foundation in the culvert. Construction of a deep and strong foundation is very important in building a bridge. A foundation along the entire breadth supports the bridge. 8. These culverts are built at less than 20 feet high over the obstruction. These bridges are constructed at a height of more than 20 feet. 9. Culverts may be pre-constructed or built on the site. Bridges are usually constructed in the site or pre-constructed in smaller parts. 10. The culverts are simpler in structure and design, so it can be constructed with less time and labor. The construction of bridges generally requires a lot of time and manpower. 11. The construction of a culvert may be done with a low budget. This structure and design of a bridge are elaborate and complex, hence its construction requires a substantial budget. 12. A culvert may be constructed to accommodate roadways both over and under the deck. This only way of transportation is over the deck of the bridge. 13. Some culverts, like box culverts, have sharp corners that are unsuitable for high-velocity vehicles. Bridges may withstand heavy and speeding vehicles. 14. A culvert is constructed when water needs to be conveyed through tunnels or channels under a roadway. A bridge is built over a body of water that is large and has variable flow. 15. Culverts prevent waterlogging, flood, and erosion, and allows water to flow its natural course under a roadway or railway. Bridges provide an easier route of transportation that saves time and reduces distance. Difference between flyover and bridge. What is flyover? Flyovers, over a flyover, underpasses, overpasses, etc. are some examples of the engineering marvels that allow for the effort of people and saving of time, vehicles, and even trains. Normally flyover is made over water bodies like rivers, but over bridges are meant to provide the roadway for pedestrians and even vehicles over a railway line or even under the flyover. The flyover is a concept that allows roads to be built over roads to facilitate faster movement of vehicles and people in this age of congested traffic at metro cities. There are differences in overbridge and flyover. The flyover is also known as the overpass that is built over an existing road or the railway in such a manner that it crosses another road or railway. It helps in saving the time for a commuter whether they are pedestrians or running automobiles and have become very commonplace at big cities these days. However, criticisms of flyovers as they lead to wastage of precious space at this form of huge pillars that go up on the existing road. But their benefits outweigh their shortcomings as they facilitate more efficient and faster transport of people and vehicles. Type of flyover. Classification of flyover bridges as per according to form. Overpass flyover. Underpass flyover. Classification of flyover as per according to material. Composite flyover. Steel flyover. Concrete flyover. Difference between flyover and bridge. No. Flyover. Bridge. 1. The bridge stands for the structure that arranges passage over an obstacle devoid of sealing the way underneath. The necessary passage may belong to a road, a railway, pedestrians, a canal or pipeline. The obstacle to be passed may range from a river, a road, railway or ovally. Flyover stands for a bridge that bears one road or railway line over another, either including or excluding supplementary roads for making communication among the two. 2. This is also used for connection purposes, but it is usually built over roads as an overpass. The bridge is constructed to connect the two different points. 3THEY are generally constructed for road vehicles. Bridges are mainly utilized for maneuvering traffic across the obstruction. They are also applied to navigate pipelines and other forms of transport. 4. They are generally constructed over road junctions, roads, streets, etc. Several obstructions on which the bridge is constructed vary from seas, rivers, valleys, etc. 5. A flyover is constructed for the purpose of making traffic less. The bridge has constructed for short distance. And bypass. 6. Flyovers are built over man-made structures such as roads, intersection, etc. to prevent congestion, and provide a more convenient way to navigate over the traffic. A bridge is built for less transportation cost and saving time. 7. Flyover connected to a junction point or ridge point like station point connected. The length of the bridge totally depends on the gap between the 2 points. 8. The flyover is built in those areas where the roads are congested. The bridges was mainly constructed over the river, valley, etc.
Thank you for watching. Please subscribe to the channel and press the bell icon.